Welcome to video 3 in rotation. Suppose you have rotation of center omega angle alpha that will take n to n prime and m to m prime. We have proved it in video number 1 that nm equal n prime m prime and the angle in between is alpha. Suppose you have another rotation r prime, center gamma prime alpha prime, that will take, here we're going to continue, this is composite, n prime to n double prime and m prime to m double prime. So same way, n prime m prime equal n double prime n prime, and the angle is alpha prime. Now if I do r prime rho r, so here n, because n, we're going to go from n to n prime to n double prime, so n to n double prime, because they are equal, because here n prime m prime and here n prime m prime, so nm will be n prime m double prime m double prime. And if you do the angle between nm and n double prime m double prime, by Charles' rule you can introduce here n prime m prime, so it's alpha plus alpha prime. What does it mean? It means if you have a rotation of center, for example w angle alpha, and another rotation of center w prime angle alpha prime, you're going to get r rho r prime is a rotation of a new center w prime you will find, but the angle will be alpha plus alpha prime. And if alpha and alpha prime is opposite, so here we have here inverse rotation, so we don't have any more rotation. Okay. Now product of two transformation is a transformation. You can do it like this. I'm going to move by the two methods. Suppose you want to find TV1 rho TV2. Okay, so this is we're going to start here by TV2, translation of vector V2. You're going to get Z prime equals Z plus ZV2. Now you have TV1, from Z prime you go to Z double prime, such that Z double prime equals Z prime plus T plus Z prime plus Z of V1, or plus TV1. But Z prime is Z plus ZV2, so you have a transformation of the sum of the two vectors. Let us take an example. We want to find TV1 rho TV2 given V1 and V2. So first of all, what do? We have Z, we're going to go by TV2. You're going to get Z prime equals Z plus V2. That's it, Z prime. Now we're going to go to TV1, translation of vector V1, so it's Z prime plus TV1, which is 3 minus I. But Z prime is this whole expression, so we replace it here. So Z double prime will be Z prime, which is Z minus 2 minus 3I plus 3 minus I. So it's the addition of 1 minus 4I. So 3 minus 2 is 1, minus I minus 3I is minus 4I. So translation T V1 rho T V2 is a translation of vector V1 plus V2. This is the formula. Okay. Now product composition of a rotation and transformation. Rotation and rho transformation is a rotation. How do we do it? Suppose you have Z. First of all, you're going to do TV1. You're going to have Z prime equals Z plus ZV1. Now we have rotation of center gamma angle alpha. So Z double prime will be EI alpha Z prime plus B. Okay, but Z prime equals Z plus ZV1 plus B. So if you expand, you're going to get EI alpha Z plus EI alpha ZV1 plus B. So here in that case, this is the whole thing is B, big B. So this is a rotation of angle alpha, but whose center is this expression over 1 minus EI alpha. Let us take example to understand it more. Suppose you have, this is a translation and this is the rotation. I gave you the center and the angle. Find the R rho T of V1. So first of all, I'm not going to apply the formula. I don't want you to memorize formula. Okay, let us do it, because we use in the old program to memorize, but now from now and on, no need to memorize anything. So here we're going to start by TV1. So Z prime equals Z prime equals Z plus 2 minus I. Then we have a rotation. So Z double prime, rotation of angle pi over 3 is EI pi over 3 Z prime plus B, I gave you the center here, W, the center is 1 plus I. So it's 1 plus I into 1 minus E I pi over 3. If you do it, you have it this one. But Z prime equal Z plus 2 minus I. Just we expand. If we expand, you're going to get this one. And if you want to find the center, it will be this whole expression over 1 minus E I pi over 3. So please don't memorize formulas. We don't need. So we do it this way directly. Now suppose I want to do the vice versa, TV1 rho R. You can check it here in general, but don't memorize it. Please don't memorize it. Suppose you have a rotation of angle pi over 2 and center W1, 2, and the translation of vector V1, 1 minus I. I want TV1 rho R. So I start by R. Z will be Z prime, because angle pi over 2, IZ. I have the center, so it's B is ZW into 1 minus I. If you do it on calculator, you have this one. Then I want to do the translation. I have translation of vector V1. So Z double prime will be Z prime plus 1 minus I. But Z prime is IZ plus 3 plus I plus 1 minus I. You have this one in complex form. So TV1 rho R is a rotation of angle pi over 2 and angle W prime. The angle W prime, ZW prime, the center, sorry, ZW prime equal 4 over 1 minus I, which is 2 plus 2I. So don't memorize, just do it as I'm showing you. Similarly, product of two rotation is a rotation, but if alpha, you can check it by yourself, this one, but don't memorize it. If alpha plus alpha prime, the angle is 0, we have a translation, we don't have a rotation. However, if alpha plus alpha prime is not 0, we have a rotation of angle alpha plus alpha prime, where we're going to determine the center. Let us take an example. Suppose you have a rotation of center 0 pi over 2 and r prime of center I, gamma components I pi over 6. Find the complex expression of r prime rho r. So I start by r. So Z prime, here Z, sorry, Z will give me Z prime here under I. So IZ, because center is 0, so plus 0. Then I have r prime. So Z double prime will be EI pi over 6 Z prime plus center here is I. So I into 1 minus A. So if you do this on calculator, you're going to get this one here. But here I have Z prime. But Z prime is IZ. So I multiply EI pi over 6 by IZ. So you have here EI pi over 6. You all know. If you multiply it by IZ, so Z here, we're going to get I is EI pi over 2. So you add the angle, you're going to get Z double prime equal EI 2 pi over 3Z plus half plus 2 minus radical 3 over 2I. And if you want to find the center W prime, you're going to do this whole expression here, half plus 2 minus radical 3 over 2I divided by 1 minus E 2 pi over 3. You're going to get this one using a calculator. You're going to get the answer faster. And if you want to have a composite of two rotation where angle alpha minus alpha, you're going to get like here a translation. Let us see it. R prime rho R, we start by R. R is Z prime equal EI pi over 4 Z plus the center, since I gave you the center, so I into 1 minus EI pi over 4. If you do your calculator here, you're going to get this answer. Then you have then R prime center 0, so it's E minus pi over 4 Z. And if you replace, sorry, Z prime here, if you replace Z prime, this whole Z prime here, you're going to get this one. If you expand, you're going to get Z double prime equals Z plus minus 2 plus radical 2 over 2 minus radical 2 over 2I. So here we have, in that case, if alpha plus alpha prime, the rotation is not anymore rotation R prime rho R, it's a translation. However, if it is not 0, we have a rotation of angle alpha plus alpha prime and center to be determined. And finally, product of two central symmetry. So suppose you have SW prime rho SW, like here. You're going to have a translation of vector 2 WW prime. Let us take example. As I told you, don't memorize. Z prime equal minus Z plus 3 and minus Z plus I. I want to find SW prime rho SW. So I start by SW, which is minus Z plus 3, and Z double prime here is minus Z prime plus I. If you replace Z prime, you're going to get a translation of vector minus 3 plus I. So the translation will be, if you see it, it's 2W W prime. You can check it here. So don't memorize formula, just do it directly.